A 50-meter long fence is used to enclose a rectangular garden ABCD using the wall AD as one of its boundaries. Let AB equal X. So if you look at this question, we were told that they've used 50 meters of fencing. So they've bought that fencing wire for 50 meters off that fencing wire. Now that 50 meters of fencing wire encloses a wall. So that wire is only what I highlight. Take note of that. The wire is only A, B, C, D. Please take note that the back represents the wall, not the wire. Okay, so this area that they've got this diagonal lines, this is the wall. There's no wire by the wall. Okay. Now, as you can see, they've stated that this forms a rectangular garden. What do we know about rectangles is that opposite sides are equal. So if AB is X, that means CD is also X. Unfortunately, we don't know what BC is, so we can't say what AD is. But AD will be equal to BC. So first question, question 9.1. Express the length of BC in terms of X. So we need to find what is the length BC. And when they state in terms of X, it means that X needs to be within that equation or within that value of BC. For example, if we find out that BC is equal to 3, that would be wrong. Why? Because there's no X in there. But if we found out that BC is equal to 3X, that could be correct because there's X in there. When they say in terms of X, it means that X needs to be within your answer. So let us find the length BC. If we look at our rectangle, what do we know about this rectangle? We know that ABCD is equal to 50 meters because there was 50 meters of wire fencing used to enclose that area. So AB plus BC plus CD will equal to that 50 meters of wire fencing bought. So we can use that equation to find BC. So we have 9.1. We have AB plus BC plus CD is equal to 50 meters of wire fencing. Now we were told that AB is equal to X, and from that we found CD, which is also equal to X based on your properties of your rectangle. So in place of AB and CD, we can now substitute X. So it'll be X plus BC plus X equals 50. From here, we can solve for BC, which will be 50 minus 2X. And that is the length of BC. It is 50 minus 2X. Yes, Sonder. What is your question, buddy? You have your hand up?
Yeah, how is it 50 minus 2x and not 25 minus x? Because BC, because you also have to account for AD. Don't you have to account for AD as well?
Remember, AD is not part of the wire fencing. Think of it as you've got this wall by your house, and say outside your house there's a patch of soil, and you want to build a little garden, and there's some dogs or rabbits or whatever in your area that will come and eat and dig up your garden and ruin it. So you want to enclose that wall with some fencing. So if this is your wall by your house, so this is your wall, and you put up this wire fencing here, here, and here to enclose your garden. Remember, you've used 50 meters of wire fencing. So A plus B plus C will be equal to 50. You've not used any wire fencing on the wall. because it's a waste. Why would you put wire against the wall? Are you protecting the garden from the wall? You're not, right? So if you think about it in terms of that, we've not used any wire fencing against the wall. That's why we can't include AD within the equation. We are only including AB, BC, and CD as part of the 50 meters because that's the areas or that's the perimeter in which the wire fencing was used. Does it make sense?
Well, thank you.
Sure. Okay, so let us proceed. Okay, now we've got question 9.2. Hence, that word hence is a continuation question. It means that you have to use information from the previous question in this current question. So because our previous question was to calculate BC, chances are we are most likely going to use BC in question 9.2. That is why they made use of the word hence. So hence, determine the value of x such that the enclosed area will be maximum. So two things that should stand out. Number one, area. Number two, maximum. Now, let's look at the first one, area. We are told that the enclosed area, which means this part inside the fencing, needs to be maximum. But if you notice, this question is kind of similar to 8.3. That area that I've highlighted in red, that's the area that needs to be maximum. Now, if you remember in question 8.3, we were told to find the value of the maximum. But if you look at question 9.2, we are told to find the x value such that this thing is maximum. So question 8.3 and 9.2 are similar, but you're calculating two different things. In question 8.3, the one that we previously did, we found the y value. Keep in mind, y represents maximum or minimum. But here in 9.2, we don't need to find the maximum area. We need to find the x value that will make the area maximum. So do you remember I previously said that we are going to use concepts from calculus to answer certain things. So if you look at a rectangle, it has a turning point, a distinct turning point as a cubic function does. So we are going to that we know, or the knowledge that we have from cubic functions in order to calculate the maximum turning point of this rectangle. It doesn't mean that we are physically calculating a turning point. It just means that we are calculating the area for when this rectangle will be maximum. We are taking knowledge from another topic and using it within this topic. So it doesn't mean that you are physically calculating when the rectangle is going to turn. Okay. Now let's read our question once more. Hence, determine the value of x. So we need to find an x value. In the end, we need to have x equals something. That's what we need to have. So we need to find the value of x such that the enclosed area will be maximum. So we need to calculate the maximum of this rectangle in a sense. So it's like saying we need to calculate the stationary point that will be maximum of this rectangle. Okay, think of it in that context. Rebone, you have your hand up. Do you have a question?
Sir, I already put it on the chat.
Please repeat your statement whereby you are differentiating what we were looking for. Oh, okay, so students that did not see the chat, the question was, what's the difference between what we were calculating for in question 8.3 and this particular question or rather 9.2. So in question 8.3, we were calculating the maximum. That is the same as saying calculating the y value of your turning point. But in this question, it states the value of x for which this thing is maximum. So if you have this coordinate here of your maximum, let's say it's x and y. In question 8.3, we calculated y. But in question 9.2, now we are calculating x. So when they say for what value of x will this thing be maximum, you calculate the x value. But when they say when will this thing be maximum, or what is the value of the maximum, you calculate y. Always remember that. If they say what is the value of the maximum or what is the value of the minimum, you calculate the y value of your stationary point. If they say for what value of x will it be maximum or will it be minimum, that is when you calculate the x value, not the y value. Okay. So let us start to calculate. We need to find the x value for when this thing is maximum. Now, a question arises. How do we calculate the maximum when we don't have an equation? Are we going to use the equation of BC, or are we going to use some other equation? Which equation are we calculating? Now let's read that statement once more. It states, hence, determine the value of x such that the enclosed area will be maximum. So we need the maximum of the enclosed area. That means our equation needs to be an area equation. We need to find the maximum area. That is why we first need to find the area equation. So what is the area equation of a rectangle? It's length times breadth. If you don't remember your area equations or your perimeter equations, I would recommend looking at a grade 10 or grade 11 textbook, maybe a grade 9 one as well, if you have a sibling in one of those grades. Grade 8 can also work. Alternatively, you can just Google them. That should pop up. So learn your area and perimeter equations. They pop up quite frequently in optimization. So area is length times breadth. Our length is the longest side, which is BC, and we know that to be 50 minus 2x. Next, we have breadth. Our breadth is our shortest side, which is AD or CD, and we know that value to be x. Now, if we simplify this area equation, we will end up with 50x minus 2x squared. So this is my area equation. Alternatively, you can even write it as A of x. That's also fine, doesn't matter. Now that we've found the area equation, we need to find the maximum of this particular equation. So how do we find a maximum? Just give me a second to fix this. That is supposed to be 2x squared, okay? So our area equation is A equals 50x minus 2x squared. So how do we find the maximum of this area equation? We know that a maximum is just our stationary points. So we are going to use the same process as we would if we were finding stationary points. So we derive once. So derive this area equation once, equate it to 0, and then solve for x. So let's derive. A prime equals 50 minus 4x. That is the derivative of our area equation. Now that we've derived, we can equate it to 0 and then solve for x. So that is going to give us negative 4x equals negative 50, can divide by -4 on both sides, and you therefore have x equals 12,5. So that is our answer. That is the value of x for which the area will be maximum. If they asked you to calculate the maximum area, you would then substitute that x value into the original area equation and get the maximum area. So let us prove that this is in fact the maximum area. So give me a second. Let us split the page, and then keep in mind what I'm doing right now, that's not part of the equation. That's just a proof so we can see that our answer is correct. You don't have to do that. So we've got x equals 12,5, and we have an area equation of 50x minus 2x squared. So let us substitute 12,5 and see what is our area. So when we substitute 12,5 into our area equation, we end up with 312,5. So this is the maximum area. We're not sure if it's in, actually, I think we are sure. We were given meters, right? Yeah, we are given meters. That means the maximum area is 312,5 meters. So if the question asked for maximum area, this would be your answer. Okay, so this is maximum area. Now, let us take a value that is lower than this and higher than this, so that we can see if it produces a bigger or smaller area. So we'll take a value less than 12,5 and we'll take a value bigger than 12,5. If any of those values yield a larger area than 312,5, it means our answer is wrong. But if all the new values that we take are smaller than the area of 312,5, it means our value is correct. So let's take a value bigger. Let's do 15. 15 is bigger than 12,5. So we'll take the area of 15. Let us do 10 as well. So we'll take one value bigger, which is 15, and one value smaller, which is 10. Now, if we substitute 15 into our area formula, we end up with 300 meters squared. As you can see, if you take a bigger x value, it gives you a smaller area. So that means so far our answer is looking kind of right. Now, let's take the smaller value, x equals 10. If you substitute x equals 10, you will also end up with 300 meters squared. So because we ended up with the same thing, let's take an even smaller x value. Let's take x equals 8. So if you substitute x equals 8 into your area equation, you'll end up with 272 meters squared. And as you can see, 272 is smaller than 312,5. So it doesn't matter whether you take a bigger x value or a smaller x value. It's not going to yield a greater area than the value of x that we calculated. So that is how we know our answer is correct. We've calculated the value of x that will produce the largest area, the maximum area. Okay, so that is question 9.2.